Dynamics. First thing you do when you see the word dynamics, oh shit, I don't have an equation for that. Once you calm down, you remember, you can't stop your hand from writing. The sum of the forces equals mass times acceleration. Next thing you're gonna do, free body diagram. Here you got your man Pete. After the push, he has some velocity in this direction. And he has, the only force acting on him is the force of gravity. So, you're gonna think the sum of the forces in the x direction equals mass times acceleration in the x direction. Since there's no force in the x direction, you got mass times acceleration. This is 0, acceleration equals 0, therefore velocity is constant in this direction, right there. Next thing you're gonna do, sum of the forces in the y direction equals mass times acceleration in the y. The only force acting on him, force of gravity, equals mass times acceleration in the y. This is where the accountant jumps out of the closet. So you got the acceleration, he's accelerating downward. If we define this to be the positive direction, this is positive, everything's good. Next thing you're gonna do, mg equals ma in the y. Masses cancel, gravity equals acceleration in the y. Acceleration in the y equals 9.8 meters per second squared, downward. Done, dynamics.
Kinematics. This is looking through a kinematics lens. After some calculations with the video and using some frame rates, we learned that the total change in time for the jump was 0.86 seconds. This is from where he starts jumping to the point he makes initial contact with the ground. So delta y is the change in height. This is 0.75 meters. Delta x is the distance the man jumped horizontally, so over those three guys, which is 1.75 meters. In order to calculate v naught, we're going to have to do some special calculations. So based off of how averages work, we know that if we add two numbers together, divide those by 2, we'll get the average of those two numbers. So we calculate velocity in the y direction, the average velocity in the y direction, delta y over 1/2 delta t. This is 1/2 delta t because if we look at a regular person jumping up and down, this person will reach the peak at half the time. Average velocity in the y direction is v naught plus 0 over 2. So, if we do some algebra, it's 2 times the average velocity, which is v naught y. So v naught y, based off of these calculations, is about 3.5 meters per second. So the average horizontal velocity is change in x over the change in time, which is about 1.75 meters over 0.86 seconds. Now, if you actually calculate that, that's approximately 2 meters per second. So now we have the horizontal velocity average 2 meters per second and v naught of y, which is 3.5 meters per second.
All right, so we're looking at this problem in 2 dimensions, in the horizontal and the vertical directions. So in order to find that velocity diagonally, we have to add up the vectors, the vector components, which are the x and the y. We have determined x and y to be positive to the right and down. And then in order to find v, we have to add up the vectors, nose to tail, as we draw in this triangle. In order to find v, which is the combined velocity, we have to use Pythagorean theorem, which is a squared plus b squared equals c squared, and then sub in vx squared and vy squared for a squared and b squared. We already found Vx and Vy earlier by finding the average, so we can plug in 2 meters per second and 3.5 meters per second, and when these are added together, we get 16.25 meters squared per second squared. Because of Pythagorean theorem, our final value is c squared, we can approximate 16.25 meters squared per second squared, times 4 meters per second quantity squared, which is equivalent to our velocity squared, which then, when we square root this, we get 4 meters per second.
Right before getting into the ground, he's traveling. He has velocity in the x direction and velocity in the y direction. So to find the angle at which he's falling, we have opposite interior angles, so which are equal. So cosine theta is the velocity in the x direction over the total velocity vector, which is 2 or over 4. So beta is the inverse cosine of 1/2, which is pi over 3 radians or 60 degrees.